Take a slow, deep breath in. And let your shoulders drop. Just settle in. Welcome to this strategy session. Think of this explainer as a meticulously designed, distraction-free environment to bring absolute clarity and structural discipline to your Cambridge A-level mathematics preparation. Today, we're isolating one of the most demanding topics on the syllabus, complex numbers. We are going to calmly deconstruct the core source materials, step by step, to help you secure maximum marks. And we're going to do it completely without the traditional exam anxiety. Consider your focus level at a full 100%. Let's begin. Okay, let's dive into this. Because this question right here is exactly where so many candidates lose their footing. Senior examiners consistently report that the arithmetic of complex numbers, the seemingly straightforward acts of addition, subtraction, multiplication, and division, is actually one of the most universally misunderstood areas in the entire mathematics syllabus. You might be wondering, why is that? Well, it's because complex numbers introduce a dual cognitive load. You see, you're no longer just tracking a single numerical value. You are balancing real parts and imaginary parts simultaneously. It's kind of like holding two completely separate conversations at exactly the same time. The high-tariff nature of this topic means the stakes are elevated. When you see an equation asking you to divide two complex numbers, your brain might naturally register a spike in cognitive anxiety. But today, we are going to fix that. We're going to establish a methodical, bulletproof approach that honors the precise assessment objectives demanded by Cambridge examiners. To maintain our focus, let's quickly map out our systematic path for this session. The challenge, theoretical foundations, our procedural framework, critical examiner warnings, and finally, evaluative thinking.
Part 1. The Complex Numbers Challenge.
You know, it's rarely the basic addition or subtraction that causes the critical failure. The true challenge lies in the mental stamina required to maintain your structural alignment when the operations become layered. The urge under pressure is to rush. You want to rush through the division, scattering your real and imaginary expansions randomly across the page, and in doing so, you lose focus on specific command word parameters. So we need an antidote to this anxiety. That antidote is the attainment of true mastery. Mastery is not merely memorizing that I squared equals -1. As our source material beautifully defines it, mastery is exhibiting a connected, conceptual understanding that is easily transferable to completely unfamiliar mathematical contexts. Top-performing students do not rely on fragile, rote memorization. They build adaptable frameworks. They understand the why behind the operations. When you multiply by a complex conjugate, you aren't just following a random recipe. You understand that you are intentionally creating a difference of two squares to eliminate the imaginary component in the denominator. This is the zen of decoding command words. If the examiner says analyze, they want the breakdown. If they say evaluate, they want a justified conclusion. Calmly peeling back the filler words to isolate those exact assessment objectives is what protects you from running out of time.
The Cambridge Assessment Framework gives us an explicit directive here. They state, the assessment framework prioritizes analytical depth over superficial breadth. I really want you to internalize that. Examiners are absolutely not looking for a shallow spread of mathematical trivia. They are looking for logical, structured, deep reasoning. They want to see the deliberate, precise strokes of your mathematical argument. When you perform a complex subtraction, distributing that negative sign with absolute precision across both the real and the imaginary components of the second complex number, you are demonstrating that analytical depth. You're showing the examiner that you respect the structural integrity of the equation.
Section 2. Mastering Theoretical Foundations.
Before you can execute the procedural steps, your theoretical foundation must be set in stone. Think of it as a theoretical architecture resting on three incredibly sturdy pillars. First, precise definitions. You must have absolute clarity on what constitutes the real part, the imaginary part, the modulus, and the argument. Second, causal relationships. You have to understand how an operation affects the outcome. Third, integration. To really see how this works, let's picture a serene, collaborative study debate between two typical top-tier students. We'll call them Alex and Sam. Alex is highly analytical and precise, but tends to crowd the page with unstructured facts. Sam is creative and dynamic, but sometimes loses focus on specific command word parameters. Alex starts by mapping out the textbook definition step by step. Alex writes, let z equal a plus bi, carefully establishing the foundation. But Sam jumps in and challenges that framework, pointing out that just defining it isn't enough. Sam says we need a clear, logical evaluative link back to the prompt. How does multiplying these two complex numbers actually affect their geometric representation on an Argand diagram? What happens to the angles? What happens to the lengths? They challenge each other's layout choices smoothly, realizing that to perfectly fit the mark scheme parameters, they need both Alex's precision and Sam's big-picture logic.
And this brings us to a crucial point, confirmed by the principal examiner reports. There is a definitive trend. Candidates who reference cross-topic connections achieve significantly higher marks. Why? Because it demonstrates the holistic, analytical depth we just talked about. As Alex and Sam continue their debate, they realize the examiner will rarely give a complex numbers question in a vacuum. It's going to be seamlessly interwoven with quadratics, polynomials, or trigonometry. When you divide complex numbers, and the result naturally flows into solving a quadratic equation with roots that are complex conjugates, you are demonstrating elite-level synthesis. You are showing the examiner that you see the entire landscape of the syllabus, not just isolated, disconnected islands of knowledge.
Section 3, the procedural framework. Let's move to and see how this builds. Okay, let's breathe and refocus. We've reached a pivotal moment in our strategy session. Before we write out our final top band paragraph structure, make sure your daily study dashboard is complete. Subscribe to Ace the Exams at Ace the Exams right now and enable all notification alerts. Whether your target is an IGCS, an O-level, or an AS and A-level A-star, this channel is your weekly space for stress-free exam mastery. Now let me offer you a deeply reassuring concept, the method mark strategy. In the rigorous environment of Cambridge mathematics, marks are not solely reserved for the final pristine answer. They are heavily weighted toward your procedural reasoning and your logical execution process. This acts as a magnificent safety net. Imagine you're executing a highly complex division. You correctly identify the conjugate, you lay out the multiplication, you expand the brackets methodically, but right at the very end, under the pressure of the clock, you drop a negative sign. Because you have adopted a calm, step-by-step methodology, the examiner will still award you the vast majority of the method marks.
To guarantee those method marks, we employ a strict 5-step standardized sequence. Think of this as your protective framework. Step 1. Identify key elements. Calmly extract the relevant data. Are you multiplying or subtracting? Step 2. Apply relevant principles. If it's division, the principle is multiplying the numerator and denominator by the complex conjugate. Step 3. Execute analysis with clear working. Enforce a pristine layout. Write out the expansion line by line, aligning your equal signs. Real parts grouped together, imaginary parts grouped together. Step 4. Verify results. Take a micro pause right here. Check your arithmetic. Did I squared correctly become -1? Step 5. Present in appropriate format. If the command word asks for the answer in the form x plus iy, ensure your final line strictly adheres to that parameter.
Proper presentation is absolutely non-negotiable. Headings, correct terminology, appropriate formats, and clear annotation. Now, what happens if you encounter a structural roadblock mid-paragraph? Imagine Alex and Sam are writing out their response line by line, creating a pristine block of text, but suddenly their evidence drops out of alignment. The numbers just aren't matching up. This is where we step in with a clear, structural framework to calmly restore balance. We use the Peel structure, adapted for math. Principle, equation, execution, link. State the mathematical principle clearly. Write the initial equation, execute the working sequentially, and link the final format back to the exact context of the question. Following Peel stops panic in its tracks and restores perfect order to your page.
Section 4. Critical examiner warnings. Let's look at where things go wrong.
Welcome to the practice arena. The wisest strategy is not just to learn what to do, but to study the exact locations where previous candidates have failed. Let's try Challenge 1, the mindful scan. Imagine a highly complex Cambridge source text on your screen right now. A 60-second visual countdown timer is ticking down. Your goal is to extract the single most high-yielding core trend. And here it is. Straight from the principal examiner reports, candidates consistently confuse key terminology, always define terms before using them. In our syllabus, this means distinguishing perfectly between a complex number, its conjugate, its modulus, and its argument. When a question asks you to utilize a complex conjugate in division, don't leave it to the examiner to guess what you're doing. Define the operation. Clear, unambiguous terminology signals to the examiner that you are a candidate operating with total precision and control.
Now for Challenge 2, the imperfect answer. Let's systematically dismantle the top 3 mistakes so you can spot exactly where structural discipline breaks down. Number 1, answers are too vague. In complex numbers, this usually looks like skipping steps in an expansion. You try to hold too much in your working memory, you skip a line, and you arrive at an incorrect real part. The examiner literally cannot award method marks because the detail is missing. Number 2, failure to check the final format.
You successfully perform a massive calculation, but you leave the answer as a fraction with an imaginary number in the denominator, ignoring the command to leave it in the expected algebraic form. Number 3, answers are not specific to the provided context. If the complex numbers represent vectors or coordinates on an Argand diagram, your final evaluation must reflect that specific spatial context. If you look at any flawed student paragraph, the breakdown almost always happens right at the transition between Step 3 and Step 4 of our framework, the failure to verify in format.
Section 5. Evaluative thinking for top marks.
We are now entering the elite phase of our strategy. To secure an A-star, you must satisfy complex command word parameters. And this brilliantly illustrates the exact difference between a mid-tier response and a flawless top-band valuation. Standard analysis merely identifies simple similarities, but comparative analysis requires identifying similarities and differences using comparative connectives, all entirely supported by mathematical evidence. For example, if you're asked to compare the results of multiplying two complex numbers versus adding them, a standard answer just lists the two final numbers. A comparative evaluative answer will observe that addition acts as a vector translation on the complex plane, while multiplication results in a rotation and a scaling of the modulus. You are using the actual algebraic evidence of your calculation to draw deep structural conclusions.
Creating a pristine, high-scoring block of analysis requires evaluating the quality of your mathematical evidence. You've got to identify any limitations in the data. You must note underlying assumptions, like assuming the roots of a given quadratic are real when the discriminant actually proves they are complex. You must consider alternative interpretations and carefully assess how these factors affect your final conclusion. Just like our scholars Alex and Sam, who now have a completed, flawless response paragraph sitting perfectly on their digital notebook. The candidate who rigorously questions these assumptions and justifies every single algebraic manipulation with concrete evidence is the one who secures the top grade.
As we bring this deep focus session to a close, let's distill this entire masterclass into 3 core focus pillars. First, the 3-step question scan, calmly decoding the precise command words before you ever write a number. Second, the marks per minute flow formula, using our 5-step procedural framework to ensure you are accumulating method marks efficiently without ever rushing. And third, the final polish review pass, executing that critical check of terminology and presentation format. I leave you with this final high-impact question. When tackling your next past paper, how will you systematically verify your evaluative links before finalizing your answer? Take a moment to really think about that. Make sure to subscribe to Ace the Exams at Ace the Exams, click the notification bell for future focused deployments, and leave a comment below identifying the specific subject, tier, and target grade you are currently meditating on. Maintain your focus, trust your architecture, and I'll see you in the next session.